Alright, so today we're going to talk about how to write a linear equation given some information. Information would generally need to give us either information about the slope or information about the points to write the particular equation of the line. So first off, finding slope, if you're given, you need to know 2 points to find the slope. And the algebraic form of the slope equation is y2 minus y1 over x2 minus x1. This is the same idea as you've probably talked about at some other time in like either grade school or middle school as rise over run. The rise is the y's, the run is the x's. The rise is the change, how far we go up or down, and the run is how far we go left or right for the x's. So we're given these 2 points right here. We do our slope, we do the difference of the y's. It doesn't matter which one you pick as y2 or y1 as long as you're consistent. If I do -5 minus a -2, since -5 came from the first corner point, I need to make sure I do 8 minus 2 on the bottom. Keep the consistent order. Well, we notice we have a double negative, so minus and negative becomes plus, so it's really -3 over 6, which when we reduce the fraction is -1/2. If we did it the other way around, if we did it as -2 minus -5, it would then have to be 2 minus 8 on the bottom. It's still going to give us the same answer. We'll have a +3 up top, but now a -6 on the bottom, so it's still -1/2 for the final slope. So yeah, doesn't matter as long as you're consistent with your order. Whichever order you do your y's in up top, make sure the x's are in the same order then. So we have this point right here, so -4, 5, -2, 5. So if we do 5 minus 5, the -4 minus a -2, we get 0 over -2, because -4 plus 2 is -2, which is just 0. So something you can do to move through it a little bit quicker is if you recognize your y-coordinates are both the same numbers, your slope will always be 0 no matter what the corner points happen to be, as long as the y's are the same. When the y's are different, and the x's are different, then we have to make sure you go through the problem like we did last time, in example 1. So when the x's are the same, it's going to be the same kind of trick we can use. So let's just kind of take a look at that now. So for our slope, if we do -7 minus 3 up top, and then -9 minus a -9 on the bottom, we get -10 over 0, and you should recognize that we cannot divide by 0. So for problems like this, we have what we call an undefined slope. That will again occur when if you notice your x values are the exact same numbers. Now when I'm saying exact same, they have to be the exact same. It can't be like a -9 and a +9, and they're both 9s. They're not the same number in that case. Same number, same sign in the x position, undefined, whereas same number, same sign in the y position, slope is 0. If they're all different, then you need to make sure you go through the full process and simplify your fraction in the end. Now you might encounter some problems which they give you the slope and require you to find one part of the quarter point. So we have 6r is the point, 3 is the other point, and the slope happens to be 2. We're looking for r. Well, we're going to set up the same way, only now we know that slope equals, we'll do y minus y, so r minus 3, over x minus x, 6 minus 3. So at the top we can't do anything, it's just r minus 3, but on the bottom we get 3. So what we'll do in these problems is, since we have a fraction, if we multiply everything by the denominator, we get 6 equals r minus 3, which when we add 3 to both sides, r equals 9. So you're just simply solving out a linear equation at this point. So instead of you being given the equation to begin with, you have to set it up on your own and then solve it out the way you would any basic algebra problem. So the missing corner point could be a y value or it could be an x value. In either case, it's still the same idea. We set our slope equation, -3/5 equals y minus y, so 10 minus 4, over x minus x, so r minus 8. So we get -3/5 equals 6 over r minus 8. Now, another way you can look at solving these problems is, especially when it's a fraction equal to a fraction, you can think of them as proportions, where we cross multiply. -3 times r minus 8 equals the 5 times the 6. So as we can see, we're distributing our -3 into that expression. So it's -3r plus 24 equals 30. So now again, we have our own linear equation. We subtract the 24 over, negative 3r equals 6, divide by the negative 3, and r is negative 2. So we could have done the same thing with the previous problem. We could have set up as 2 over 1 and just cross multiplied. You find you'll get the exact same answer. So ultimately it doesn't matter whether you see it as just multiplying by your denominator or you have two fractions so you cross multiply. In either case, you're going to get a linear equation left over, and then you're going to just simply solve it out. Now, that's how we work with slope. Now, if I want to write the equation of a line, we always need the slope and a single point. So they give a slope and point. We're just going to plug those values into y equals mx plus b, where the y value of that equation is the y-coordinates, the m is your slope, and the x value is your x-coordinates, and use it to solve for b. That tells us the y-intercept, and we can then write the appropriate equation from there. If we're given 2 points, we don't know the slope then. We have to then find the slope given the 2 points, and then plug one of those 2 points in with the slope to write the equation of the line. And that'll look like this. So we're given the corner point negative 6, 8, and the slope is 3/5. So we plug into y equals mx plus b, we do our y-coordinates equals our slope times our x-coordinates plus b. So for this particular equation, the negative 6 and 3/5 don't go nicely, unfortunately. That's fine. Negative 8 equals a negative 18/5 plus b. So if we think of our 8 as 40/5, you can add the 18/5 to both sides. Single fractions is really not that bad to work with that instead of having to clear out the denominator. We just simply rewrote 8 as a denominator of 5, which means it had to be a 40 for the numerator. So negative 40 plus 18 is a negative 22. So it's negative 22/5 is our b value, which means our equation would have been 3/5 x minus 22/5. And there's our equation in slope-intercept form. Again, using the point, using the slope to write out the equation of our line. Again, plugging into y equals mx plus b, and then rearranging that equation to solve for b so we can actually write the particular equation we want. If we're given the 2 points and not given the slope, we find the slope first. So y minus y over x minus x. So in both cases we're minusing a negative, so that becomes plus. 12 plus 4 is 16. Negative 4 plus 2 is negative 2. So we get a negative 8 for our slope. And now it doesn't matter which point we plug in with, either negative 2, negative 4, or negative 4, 12. Ultimately up to you. I'm going to use the negative 2, negative 4. The number is a little bit smaller, so it's probably a little bit easier to work with. So it's the y value equal to our slope times the x value plus b. So negative 4 equals 16 plus b. So if we subtract 16 from both sides, we get negative 20 equals b. So our equation would be y equals negative 8x minus 20. If you want to be sure that you did it correctly, you can always plug in the x-coordinate from the other equation and make sure you get the same y value of 12 in this case. And so if we did that, negative 8 times the negative 4 minus 20 is positive 32 minus 20, which is 12, so we know we did it correctly. Again, that little check step at the end is not completely necessary. You can do it if you wish, but as long as you're plugging in, you found the slope correctly, and you plugged into y equals mx plus b correctly, there's no need to do that. Now, in addition to writing equations of just lines, we also need to talk about parallel and perpendicular lines. So two lines are parallel if they never intersect, whereas two lines are perpendicular if they do intersect, but intersect to form a right angle. It turns out the slopes of these particular lines are related to each other, where parallel lines will have the exact same slope, which makes sense seeing as they never intersect, so the change in y and change in x should be the same kind of concept, whereas perpendicular are negative reciprocal slopes. So for example, if our slope was 2/7, parallel would be also 2/7, whereas perpendicular would be negative 7/2. So for these kind of problems, we'll be given an original equation, and we'll be asked to write the equation line that happens to be parallel or perpendicular to that line through a given point. So for example, right here, we want to know the equation line that's parallel to this equation through the negative 8, 2 points. Well, our parallel slope is also going to be 3/4. So we use the given point, negative 8, 2, and 3/4 to write the equation. So it's going to be y equals m times x plus b. So we multiply the negative 8 and the 3/4, we can get a negative 6. So we add 6 to both sides, we get 8 for b. So the equation would be y equals 3/4 x plus 8. So again, that's our parallel problem. So perpendicular is the same general idea. The only difference is now we use the slope given the equation, negative 2/5, and recognize that perpendicular will be a positive 5/2. Again, it's the negative reciprocal. So we flip the slope around and change the sign. So keep in mind, if your original slope was, let's say, 3, your perpendicular slope, the upside down t is the symbol for perpendicular, then be a negative 1/3. So just be careful if it's just a whole number for those problems. Anyway, so again, for this one, our slope is 5/2, and our point is 6, 1. So we just plug into y equals mx plus b. 1 equals 5/2 times 6 plus b. So when we do 5/2 times 6, we get 15. We subtract the 15 to get negative 14 for b, which means our equation had to be y equals 5/2 x minus 14. There's the equation of our perpendicular line. So again, whether it's parallel or perpendicular, it's the same general concept as writing an equation in general. The key is identifying the slope from the given equation, where parallel is the same slope, whereas perpendicular are negative reciprocal slopes. And once we have the slope of the one we want, we just use the coordinate point given to us to write the equation of the line. Okay, so that's it for writing equations of lines. I will see you next time.